Now, students, today we are going to study about acceleration due to gravity and its variation. Now, up to now, we have got the idea that what is the meaning acceleration due to gravity, and we have got the idea that acceleration due to gravity actually is not constant everywhere on the surface of Earth, but it changes as we go higher. Then it decreases, and as we go deeper inside the earth, even in that case also it decreases. Up to now we have got the idea about acceleration due to gravity and how it can vary. We have got the idea. These days actually we are studying gravitation chapter. First few points I will revise, and then we will switch over to variation of g with depth. Actually I explained earlier what is the meaning gravitation. The meaning of gravitation. Actually, meaning of gravitation is very clear. It is a phenomenon in which two bodies attract each other due to their mass. Gravitation is a phenomenon of attraction of one body by another due to their masses, and the force is known as force of gravitation. Actually, this force of gravitation was given by Newton's law of gravitation. Earlier we have seen this. What is the meaning of Newton's law of gravitation? If two bodies are there having mass m1 and m2 and kept certain distance r, then body 1 is attracted by 2, in return body 2 is also attracted by 1. Now these two equal and opposite forces have equal magnitude. This is the sign magnitude, and this force actually, according to Newton's law of gravitation, the magnitude of force directly proportional to product of the masses and inversely proportional to square of the distance between them. If we will combine these two, we get m1 m2 by r square. A constant we are using here, that is called universal gravitational constant, or simply gravitational constant. Its value where proportionality constant is known as universal gravitational constant. Anywhere in the inverse its value is same. Its value actually was first experimentally determined by Cavendish, and it came 6.67 into 10 to the power minus 11 Newton meter square per kg. Now when we are talking about this formula, this is one of the basic formula in gravitation. Still, it is after 350 years since it passed, but still this formula is used to send satellite in the orbit of Earth. This one single formula is used for different purpose, for expression for orbital velocity, or if any satellite has to send outside the gravitational field of Earth in the deep space, then escape velocity is required to provide. But the expression of escape velocity, the expression of orbital velocity, it could be determined using this formula. This formula gives the calculation of gravitational force. Now when we are talking about characteristics of gravitational force, there are different characteristics of gravitational force. Earlier also I explained. Gravitational force is a weak force. Between smaller bodies. But it is a stronger force. It is dominant force when heavenly body is concerned. Bodies are considered, such as stars, planets, etc. So gravitational force is a weak force, weakest of all four fundamental forces. But when we talk about big bodies, heavenly bodies, having greater mass, then that is not the case. So different characteristics we have earlier also got the idea. Now I explain later on acceleration due to gravity. And how it varies. Acceleration due to gravity, the value of acceleration due to gravity, and we got the expression gm by r square. Where r is the radius of Earth, m is mass of Earth, and if you are putting here, we can calculate the value of g. That approximately comes on the surface of the Earth 9.8 meter per second square. On the surface, let the point A is on the surface of Earth. But when we come deeper, maybe at depth d from the surface, then what will happen at this point B? What will happen about this acceleration due to gravity? That we can study. Variation of g with depth. variation of g with depth. So let us consider Earth as a sphere. So it will have volume V and maybe uniform density of the material of the Earth is rho. So mass of Earth m could be volume of Earth into density of Earth. So what happens in volume? It is 4 by 3 pi r cube, and maybe uniform density. This we can put here using 2 in 1. We get and finally so we are getting 4 by 3 pi r g rho. This is on the surface of Earth. 4 by 3 pi r g rho. Now what happens when we go depth d inside Earth? Then at point B, what will be the acceleration due to gravity? Let it is gd. At point A it is g. Now what will happen about gd? Let us find out. For that, we draw a small sphere. So the mass in this small sphere is responsible, having radius of this small sphere r minus d. So if you are comparing the acceleration due to gravity, then 4 by 3 constant, pi constant, g constant, rho constant. So here at the depth d from the surface of Earth, acceleration due to gravity gd So let us divide this 4 by 3, gd by g. Dividing 4 by 3, and we get LHS, left hand side gd by g, and this side what we get, 4 by 3 pi r minus d divided by, then we can cancel out common terms, rho cancel, capital G cancel. So what we get, r minus d by r, 1 minus d by r, and here so we get, so when we are doing cross multiplication, So we are getting here gt is equal to g1 minus d by r. So as we go deeper and deeper, d value will increase. So as we go deeper and deeper, acceleration due to gravity decreases more. Here d is distance from the surface. Distance from the surface of Earth. These formulas are very important to calculate acceleration due to gravity at a particular depth. Very important to calculate acceleration due to gravity at any depth. We will solve a numerical problem based on this formula, and we will see how to calculate what could be the percentage change in acceleration due to gravity. That also to find percentage change in acceleration due to gravity at any particular depth. Or we can find ratio also. We can find ratio of acceleration due to gravity at two depths. So we will solve later on. We will solve numericals based on this. And for today we should remember this formula, and we are stopping our discussion. We will continue our discussion next day. Okay students, thank you everyone.